Hey guys, so in this video I will continue on the series I started in the last one, where I've built a React Native Turbo module with Swift, and we'll build on top of the very same code we used last time. So please check out the description where I have this repository linked in. It will be the first step that we'll start on in this video. So the topic for today is event emitting. Which is a way for us to inform JavaScript about a change that happened in native. So let's say on the example of the native local storage, where a new key is added, we want to send a message, send actually an event on key added to JavaScript, so JavaScript can react to those events. And I'm sure you used many libraries that are doing the same, where they inform you about something that happened on native in JavaScript, and this is very, very useful mechanism that you can use. So yeah, here in the native code, we will call an function, an auto-generated function by Codegen called emit event. We will send some event data, and then on the JavaScript side, we will set up a listener inside of useEffect that will allow us to react to those changes. So yeah, let's jump in. Remember to clone the repo, as we will be starting off at this point. All right. So first step to add a new event emitter and to actually emit events is to define the type that we want to emit. So in our case, it will be a key value pair with the key string and value string. And we need to add a new read-only field in here, like so, and update the import. And so this is adding a new type on key added of the type Codegen types at event emitter and passing in this key value pair as a parameter. And now we need to rerun Codegen so it regenerates all of the code, and we will examine the code in a second. All right, so Codegen finished, actually CocoaPods finished installing, so let's do xcd iOS. And now we can go to localstorage.h, and let's see what else we have here. Right, so you can see this native local storage spec that we talked about in last video. So this didn't change, but in here we've got a new interface generated, native local storage spec base, which now has a new emit on key added method that we can use. It also stores the event emitter callback and some additional things we don't need to get into, but yeah, we need to copy this native local storage spec base and change it from this ns object to this one. So now our class inherits from the native local storage spec base, and it implements the protocol native local storage spec. So now in here, let's say we want to emit an event here, we can do south emit on key added and pass in the dictionary. But we want to do all of this from Swift, so let's jump into the Swift side and modify the code there. So in here, as the first thing, we need to store the closure, which is how in Swift we call a callback. So we will be storing this callback in this variable on key added. Okay, so first things first, we need to override the initializer so we can pass the data from Objective-C to Swift. So in order to do that, we need a new public init, and we pass in this very same type on key added that accepts ns dictionary and returns void, which means returns nothing. And in here we will do self that on key added equals on key added. So our local self, our local on key added equals the one we passed in. And as you can see, we've got an error because we need to do add escaping, which tells Swift that the closure that we pass in will outlive the function call. So this on key added closure won't be used immediately. We will use it later, so that's why we store it to call it later. So we need to tell the compiler, okay, don't deinitialize it immediately. Let us use it later on. So this is what the escaping key is doing. Okay, so next thing is to, inside of set item, we need to add on key added and actually call it. And the logic for it is that if the string for a key we are adding is nil, then we will call on key added. So if the key is not in our user defaults yet, we call on key added because this is most likely, this needs to be a new key in that case. And otherwise we just set it and we notify JavaScript only about new keys. Okay, and that's pretty much all that we need to do on the Objective-C, on the Swift side. So let's jump to Objective-C. And now we will see an error next to init because we override like we changed the default initializers. So we need now to pass in init on key added. All right, if you keep pressing enter, it will fill in this placeholders for you. So now we can do dictionary, let's call it values. And we can do self emit on key added values. So these are the values passed in from the Swift side. And we just call self emit on key added. And yeah, all of this seems to be working well. We can actually compile and see. All right, so the app compiled successfully. As you can see, no errors. But as a spoiler, I want you to maybe try to find what might be wrong with this code. If you know some of Swift and Objective-C, you might already scream at your monitor saying, like, you cannot do this. And yeah, that's what I want to get into now. So why this code is has one major big flaw. So in order to understand that, let's jump into excalidraw one more time. And so Swift and Objective-C, they use arc, which is, and this is how they manage memory. So this is automatic reference counting. So each object that has a reference counter, and as more objects point to it and like hold its reference, the counter increases. And so basically the counter counts how many strong references are pointing to this object. And in our case, the Objective-C class called local storage, it holds one strong reference to the Swift class, which makes sense. We want to hold the reference to it as we are calling functions, because otherwise it will just crash. So we have to hold reference from Objective-C to the Swift class. However, now we introduce something called a retain cycle, because local storage class from Objective-C still holds a reference to the Swift class. However, now also the Swift the closure that we pass in from Objective-C references self, which means that now Swift also holds a strong reference to our Objective-C class. So if we go back here, you can see that we pass in the closure, which inside of it references self. And this is a pretty big issue because now we'll have this kind of a deadlock that both classes hold strong reference to each other. So in order to get around this issue, we have to first do __ weak local storage. So we get a weak reference to our self, which in this case is the local storage class. And then in here, we can call weak self emit on key added, which now breaks this retain cycle because only Objective-C holds strong reference to the Swift class and not the other way around. So yeah, now we can recompile and see if all of this works properly. So let's go to, in the meantime, let's go to the test code and add a use effect. And this is calling local storage on key added. And when this event is fired, we will just call alert. And when this function is returning, so when this component is on mounting, we will remove the subscription. So we won't keep listening onto this event whenever this component is not mounted. Okay, and let's add a new pressable that will store a random greeting. So this way we will do greeting.map.random, which will give us every time a new key. So we will see that this event is actually coming in. So now when we press to store greeting, nothing happens because this event shouldn't be firing. We already have this key set in our local storage. But now when we do press to retrieve, we can see a new key added, greeting with this random number and value hello expo. You can also press to retrieve, everything still works. And yeah, let's also press up the breakpoint in here. And let's examine the call stack. So here, all of this is like first caller is set item. So this function is called from JavaScript, which we set item. Then we jump into Swift. So in here you can see our Swift code and we go into this if saying that this key is undefined. We can even examine the key, greeting and some random number. And then we go back to the Objective-C closure and we emit on key added. back to JavaScript. So we go from JavaScript to Objective-C to Swift and back to Objective-C and back to JavaScript. So yeah, this is how it works, and you can see alert now being displayed again. So yeah, thank you so much for watching this video. I hope you learned something new, and if you enjoyed it, please leave a comment saying what you would like to see next. And yeah, thank you. Bye.